So the last topic for today would be linear independence, and it's going to be as short as possible. But I need you to understand it because or linear or co-linearity. Because when we go into Python, we're going to be testing for co-linearity within our data, and you'll be wondering that what's the meaning of co-linearity? So this is what linear dependence is, right? Co-linearity is a feature. Okay, let me just write it down for. So co-linearity is a feature. Is a feature. Sorry, is a phenomenon. In a feature variable. In a regression model. Where close my door. Where one feature is highly is linear correlated with another feature variable. This is my definition. So it's okay. It's okay. Is a phenomenon in which, not in a feature variable, in which a feature variable in a regression model is linearly correlated with another feature variable. So in machine learning, you'll be having situations like this, right? So they'll give you variable A, variable B, variable C, variable D, variable E, variable F, and ask you to predict variable Y. Variable is like features. So for example, let's say we want to predict the price of a house. Feature A could be the size of the bedroom. Feature B could be the size of the lawn. Feature C could be the local government. Feature D could be anything, right? So they give you lots of features, and you're supposed to pass these features through your computer to learn from them and predict what the optimal price of the house should be, right? You will test for collinearity in Python much later. And collinearity is just saying, is feature A linearly correlated to feature B? Is feature B linearly correlated to feature C? Because if you have linear correlation between your variables, then your model will start to do something we call overfitting. Right? So we want to check out what collinearity or linear independence means in just simple mathematics. So for example, there are two, okay, let me do it this way. There are two ways you can know if a feature is linearly correlated. The first way is if addition of the vector of one vector results in another vector, or one vector results in another vector. I will explain. Or two, if one of the constants is non-zero, then we have collinearity or linear dependence, or linear dependence. And then if one of the constants is zero, right, then we have linear independence. So I'll take a couple of examples. The first example I'm going to give you is, so we have two vectors, vector A is equals to 2, 3, right? And vector B is equals to 4, 6. So you can see that multiplying vector A by 2 gives us vector B, or multiplying vector A by vector, or adding vector A to vector A gives us vector B. So you can say these two vectors show collinearity, or they are linearly dependent. Or in another example, if we have 3 vectors, right? Vector A is 2, 3. Vector B is 7, 2. And then vector C is 9, 5. Now, are these 3 vectors linearly dependent, or do they show collinearity? The answer is yes. But you can see that 2 plus 7 gives us 9. 3 plus 2 gives us 5. All right. So these vectors show collinearity or linear dependence. But now let me give you a last example that explains this second condition. That says if one of the constants is non-zero, then we have linear dependence. But if one of the constants is 0, then we have linear independence. So let's clean this up. This will be pretty rough. So I need you to write down as I'm writing. Right? So let's say we have vector 2, 1 as vector A, vector 3, 2 as vector B, and then vector 1, 2 as vector C. On inspection, you can see that they don't satisfy the first condition. 2 plus 3 won't give us 1. 1 plus 1 won't give us 2, right? So let's see if they are linearly dependent or independent, or if they show collinearity. So let me give them a constant, right? So C1 in bracket 2, 1 plus C2 in bracket 3, 2 plus C3 in bracket 1, 2 will be equals to 0. So let me solve for the x hyperplane. This is the x-axis, right? So in solving for that, now I have 2C1 plus 3C2 plus C3 equals to 0. Now I'm solving for the y hyperplane. This is 1C1. So this is C1 plus 2C2 plus 2C3 equals to 0. Now, one way to solve for this is to make C3 redundant, right? So let's say if C3 equals to -1. So let's say if C3 is equals to -1. So we'd have 2C1 plus 3C2 -1 equals to 0. And then we have C1 plus 2C2 minus 2 equals to 0. Another way to solve for, to eliminate C1 is to multiply this second one by 2, second equation by 2. So what we have is this. So what we have is 2C1 plus 3C2 minus 1 equals to 0. Then we have 2C1 plus 4C2 minus 4 equals to 0. So if we subtract this from this, we have 0 here. Then we have minus 1C2 equals to, this is minus 3. Oh, sorry, this is 3. If you take it to the other side, it's going to be minus 3. So minus cancel minus, C2 equals to 3. So C2 is 3. Let's get the value for C1 now. We can get the value for C1 by saying C1 plus 2C2, which is this initial equation here, right? We want to substitute into this initial equation. C1 plus 2C2 plus 2C3 equals to 0, right? So C1 plus C2 is 3, right? So 2 times 3 is 6. C1 plus 6. C1 is minus 1. So this is supposed to be minus 2 equals to 0. So C1 at the end of the day equals to minus 4. Right? So we have our condition says if one of the constants is non-zero, then we have linear dependence. But if one of them is 0, we have linear independence. So basically, this one shows what? Linear dependence, right? So let's go and substitute. Let's go and do a substitution reaction. C1 is minus 4. So let me see, how do we do? We have C1 at the beginning, right? I want to substitute into here. So C1 in bracket 2, 1. Then we add plus C2 in brackets 3, 2. Plus C3 in bracket 1, 2. In bracket 1, 2 equals to 0. Right, C1 is minus 4. So C1 is minus 4 in bracket 2, 1. Plus C2 is 3 in bracket 3, 2. Minus 1 in bracket 1, 2. This will give us 0. So let's take the first hyperplane. Minus 4 times 2, that's minus 8. Plus 3 times 3 plus 9 minus 1. So this minus 9 gives us 0. Minus 4 times 1, that's minus 4. Plus 3 times 2, that's 6. Minus 2, that's minus 6 minus 6 equals to 0. So this shows what? So these three vectors are linearly dependent. They show co-linearity. So if you find co-linearity in your model while doing machine learning, all you just need to do is to remove one of those vectors. So for example, I could just remove one of these vectors or remove this one and then run my model once again. So I'm showing you what collinearity means in simple mathematics. It will be very impossible for me to show you collinearity in simple mathematics when the model is very huge and you have 30,000 training examples, right? But this is just a very simple way to show you collinearity. So that will be the end of the class for today. And I'll have a very simple assignment for you, right? So on Monday morning, vector 7, 2, vector 5, 8, and vector 1, 3. I want to see if they are collinear or not, if they are linearly dependent or not. So that's your assignment for Monday morning. Thank you very much. That will be the end of this class.